Understanding the difference between a layer and a tier. 1. Definition and context. In computing and software architecture, a layer refers to a logical division or component within an application that handles specific tasks or functionalities. Layers are designed to promote modularity, with each layer responsible for a distinct aspect of the application, such as presentation, business logic, or data access. Layers facilitate code organization, reusability, and maintenance by separating concerns and promoting cohesive software design. For example, the presentation layer manages user interface interactions, while the data access layer handles database operations. 2. Functionality and interaction. Layers communicate through well-defined interfaces or APIs, application programming interfaces, ensuring that each layer can interact with adjacent layers while remaining independent of their internal implementations. This separation of concerns allows developers to modify or replace individual layers without affecting the entire application, promoting flexibility and scalability. In software development frameworks like the OSI, Open Systems Interconnection model, layers are organized hierarchically, with each layer contributing to the overall functionality and performance of network communications. 3. Definition and structure. On the other hand, a tier refers to a physical or logical grouping of hardware and software components that collectively serve a specific function within a distributed application or system architecture. Tiers are often categorized based on their roles, such as presentation tier, client interface, application tier, business logic processing, and data tier, database storage and retrieval. Tiers are interconnected to facilitate data exchange and application workflow, ensuring efficient communication and resource utilization across distributed environments. 4. Architecture and scalability. Tiers are integral to scalable and resilient system architectures, enabling distributed processing, load balancing, and fault tolerance. For instance, a 3-tier architecture, client-server model, separates user interface, application processing, and data management into distinct tiers, optimizing performance and resource allocation. Tiers may be deployed across multiple servers or cloud environments to support varying levels of traffic, user demand, and data processing requirements, enhancing system responsiveness and scalability. 5. Deployment and management. Layers and tiers are deployed and managed differently in software development and IT infrastructure. Layers are implemented within a single application or service, encapsulating specific functionalities and interacting through defined interfaces. Developers use layering to structure codebases and manage dependencies effectively. Tiers, however, are deployed across distributed systems or networked environments, requiring coordination and integration to ensure seamless operation and data consistency across multiple nodes or servers. 6. Complexity and integration. Layers focus on functional decomposition within a software application, promoting modular development and encapsulation of business rules and processes. Developers use design patterns like MVC, Model View Controller, to organize layers and streamline application development. Tiers address system architecture complexities by distributing workloads, managing resource allocation, and optimizing performance across multiple tiers. Integration frameworks and middleware facilitate communication between tiers, ensuring data integrity and transactional consistency. 7. Scalability and performance. Layers enhance software scalability by enabling incremental updates and enhancements to specific application functionalities without impacting overall system stability. Developers leverage layering to implement microservices architectures, where each microservice represents a self-contained layer with independent scalability and deployment options. Tiers support horizontal and vertical scaling strategies by distributing processing tasks across multiple servers or cloud instances, optimizing resource usage and accommodating growing user demands. 8. Summary and application. In summary, layers and tiers play distinct yet complementary roles in software architecture and distributed system design. Layers focus on functional decomposition and modularization within applications, promoting code reusability and maintainability. Tiers address system-level scalability, performance optimization, and fault tolerance by distributing application components across multiple physical or logical layers. Understanding the differences between layers and tiers is essential for designing robust, scalable, and responsive software applications and distributed systems.